Hi guys, it's Miss Canaire. Today we are going to focus some more on exponents because I know that this is everyone's favorite thing to talk about. So first thing on the top of your paper is a list of the 5 really important exponent properties and just examples of what each of them mean. So if you look at the first one, we talked about this one before, that if you have 2 things being multiplied together, we are going to add the exponents to get 9 in this case. So that's a very, very important one. I don't want you guys to forget that one, because that's very similar to the next one, where when we multiply the exponents, that's when they're like right next to each other. When you have 1 inside the parenthesis, when you have 1 outside the parenthesis, that is when you multiply them together to get the 12. So those are 2 that I saw a lot of people continuing to mess up, so be very careful about those 2. The next one is if you have 2 things that are being divided, we're going to subtract the exponents to get 5 in this case. The other one is what happens when you have a negative exponent. That's when you flip it over the fraction. So you see it here, it's on the top, but when we make it positive, it's in the bottom. That's how you deal with a negative exponent. You flip it over the fraction. We flip this over here to make it positive. And the last one, which would be one of your favorite exponent properties because it is by far the easiest, that one says that anything to the 0 power, that it doesn't matter what I put inside here, it will always be equal to 1. So for the rest of this video and the next, we're going to kind of dive into the different exponent properties and do a lot of different examples with them. So that being said, let's jump right into the first one. If we have 2 things being multiplied together, first thing, let's look at the numbers. I've got 4 and I have 3 and 4. 3 times 4 is 12. And then if you also look, I've got x to the 5th and x to the 6th. I hope that you, by now, can tell me what operation we're going to use to figure out what my exponent is going to be, and it is addition. And 5 plus 6 is 11. So we multiplied the 2 numbers together, we multiplied the 3 and the 4 together to get 12, and we added those exponents together to get 11, or x to the 11th power. Okay, looking at example 2, it's the same sort of thing. So we have an invisible 1 that's out front here, and 2 times 1 is 2. Then from there, we're multiplying everything else, so I'm just going to add the exponents, so I would get y to the 12th power. That is the first 2. All right, the next 2, same exact thing. So 12 and 2, 12 times 2 is 24. Same thing, add your exponents together. We have a to the 4th times a to the negative 2nd. Just add those together. 4 plus a negative 2 will give me a positive 2. There we go. Next one. 3 times 7. Look at the numbers first. 3 times 7 is 21. Same thing. We're just multiplying here. That's what this little dot means. So I'm going to add my exponents together. So I would get b to the 10th power. Pause the video if you need to stop and record anything down on your own sheet. Last 2. A little bit trickier. So, first things first, look at the numbers. So remember, we have an invisible 1 out here. So I've got a 3 and a 1, which will give me a 3. I'm only going to add the exponents together if they have the same variable. So if you look here, we have a to the 6th and a to the 3rd. So I'm going to add those together to get a to the 9th. Okay, same thing with the b's. I've got b to the 9th, b to the 1st. Add those together, you get b to the 10th. Again, feel free to rewind, to pause if you need to recap anything. Moving on to the last one. Same thing as example 5. So start with the numbers. So we've got 4 and we have 8. 4 times 8 is 32. From there, let's move on to the x's. So I have an x squared and an x to the 0 power. Remember, x to the 0 power is 1. In this case, 2 plus 0, I'm going to look here, I'm going to look here. 2 plus 0 is 2. Last thing, let's deal with the y's. I have y to the 8th, y to the 2nd. 8 plus 2 is 10. There we go. That's how it works for when we are multiplying and when we add exponents. I want you to pause the video right now and practice the couple example problems on your own. All right, I hope that helped, having seen a couple examples and doing a couple examples right away. Okay, next thing we're going to dive into is what we call the power to a power. And remember, like the first slide said, this is when we're going to multiply our exponents together. So 3 times 5 is simply 35. That's all we are doing for that. We cannot simplify that anymore. We can't do that any other way. We are not adding the exponents together. We are multiplying them together. Same thing here. X to the 2 times 9 will give us 18. That's all that we are doing for those two examples. All right, let's move on to something a little bit trickier. So I saw a lot of people make this mistake in the quiz, and you have to be very careful. Because what we have to do is we have to treat these two things separately. So I'm not just going to deal with the x, I also have to deal with the 2. So what this is saying is you're taking 2 to the 3rd, but you're also taking x to the 6th to the 3rd. I'm breaking that into 2 separate pieces. So 2 to the 3rd, that is not 6. That is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. All right, so now this looks familiar. This looks like one of the problems that we did earlier. 6 times 3 is 18. 8x to the 18th is your final answer for that one. 14 is very, very similar. Same thing. Remember the 4 and the x, we have to treat them separately. So I'm going to take 4 to the 3rd and x to the 3rd to the 3rd. Okay? 4 to the 3rd, that is not 12. That is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. And then the last thing we have to deal with is these exponents over here. Remember, you multiply them together, so we will get x to the 9th. There we go. That's power to a power. That's when you multiply them together. All right, 2 more. So, before we do anything, though, we should always see if we can simplify what's going on inside the parentheses. So, for example, right here, we can simplify this a little bit. There's an invisible 1 out here. What is 4 times 1? Oh, I hope everybody said 4. All right, we can simplify this. This goes back to that first rule that we just did. X to the 5th times x to the 3rd. We are going to add those exponents together, and we will get x to the 2nd power. However, that's not it. We're not done, because we still have to take this whole thing to the 2nd power. All right, so now we're back to just like these last 2 examples that we just did, we are now back to here. So I have to treat these 2 things separately. So this is going to be 4 to the 2nd and x to the 2nd, all to the 2nd power. All right, 4 to the 2nd, that is not 8. That is 4 times 4, which is 16. I almost wrote 8. Oops. And remember this. Multiply your exponents together, you get x to the 4th. There we go. That's our final answer. This is it right here. So it took a little bit of an extra step. All right, 16. Same exact sort of thing. Let's look inside to see if we can do anything first. So 3 times 4 is 12. X to the 7th times x to the negative 2nd. Remember, we add the exponents together when they're the same row like that. So that's going to be x to the 5th. And it's that whole entire thing all squared. So again, remember, you have to take these 2 things separately. And we're squaring both of those. So that is 12 squared and x to the 5th squared. Okay, 12 squared, that's okay. It's a little bit of a bigger number. That is 144. And remember here, we're going to multiply those numbers together, so we will get x to the 10th. That is our final answer to that problem. All right, so from here, I want you to stop this video, and I would like you to practice on your own using just these 2 rules that we have covered so far. I know you can do it. Please focus and try your best.